typically the type of places where you're not going to have.
Hey, thank you for coming, guys. For anyone who doesn't know, I'm Mariah. I organized this meetup among many. This is one of my favorites. I don't think I have any announcements by way of things to announce besides I have a raffle for a 1-year JetBrains subscription for one JetBrains service. So you cannot use it for all of them, just one. But anybody who, so I'm just going to pull from the Meetup API. So if you've RSVP'd for tonight's meetup, you're already automatically entered. If you haven't RSVP'd, do that before the end of the meetup. And if you leave, you don't get it. You have to be here because I don't want the hassle. You can check us out on Slack. Sometimes I post cool things. Other than that, I'm going to go ahead and we'll turn the time over to Eric. He can introduce himself, do whatever else he wants. Time is yours.
Cool. So let me just plug in my laptop real fast. All right. Awesome. Hi, everyone. It's really great to be with you tonight. My name is Eric. I'm a senior at Brigham Young University right now, also a data engineer intern at a company called Inside Sales. So we use Docker for everything that we do. So it's actually, it's a little funny because I feel like the breadth of experience that we have in this room is everything from like super Docker beginner to like way beyond anything I could ever teach you. So it's an honor to be able to introduce it to some of you, and maybe for the rest you know it, you can just correct me, heckle me as we go, because I'll need it. But yeah, so if you haven't read this, just take a moment, read it, laugh. I think tonight is going to benefit you. Cool. Yeah. What even is a dev environment? I don't know. If you don't know what it is, then hopefully this won't fall flat tonight. But so I'm gonna start off with the story. So there we were, me and my friend. We were up till 4 a.m. We wrote a web scraper in Python, and it's like classic data science project, super basic. So 4 a.m. finished the web scraper. We were actually scraping LinkedIn, and our accounts were blocked for some period of time. But besides that, like before we even knew we were going to get blocked, we wanted to be able to run this thing like all the time. Like it was our dream to put our scraper into production. So we wrote the web scraper, and then I told my friend as he was leaving, I was like, dude, Caleb, like I'll just take care of it tomorrow morning. I'll get a VM going on Amazon Web Services. I'll put our web scraper there, and like it'll just run. I'll let you know when it's done. So got up the next morning, and I spun up an EC2 instance, which is just a virtual machine in the cloud. And I was greeted with this terminal output, which I'm sure all of you have seen something like this before. But I wasn't deterred because, you know, this happens all the time. It actually happens so much that I bought a book that actually explains what to do anytime you find yourself in the situation where you have this kind of stuff coming out of your terminal. Amazing book. The Inception. So, of course, like, web scraper's broken, I got my book, so we enter something that I like to call the debug cycle, where you come in, and for some indefinite amount of time, you have no idea when it's going to end. You just go through the cycle, and you just copy and paste stuff until it works. So that day, it was a Saturday, I slept in, so I woke up like 10:30, and then it took me 10 hours to finally get this web scraper up and running in the cloud. So 10 hours of this debug cycle before it finally went. And I was like, surely there is a way. Surely someone has come up with some solution where I won't have these problems. So where did they come from? What are the problems? So here's the web scraper. I try to be really visual. I spent a lot of time on the slides, so we got some icons up here. But the web scraper was written in Python, specifically Python 3. The boxes here are just little packages that it needed. A particularly problematic one was Selenium, which is just it's a cool package. It basically lets you remote control a browser. So like you can automate any task with Google Chrome. So yeah, I was using Google Chrome. One problem was I was using it on my Mac, but the VM I was using was a Linux thing, so I needed a special Linux VM. So here's all the dependencies. These are versions of dependencies. So if you've ever messed with programming projects before, trying to like get your code to all run together, installing your dependencies, you might not have thought about this, but if you've been working for a while, you probably have. Every software package that's ever released is constantly being developed. And so as new updates are coming out, a new update equals a new version. And new versions of software break old versions in some cases, not all cases. It's actually totally unpredictable. So who knows if your application working today will work tomorrow. So just to put it into perspective, Google Chrome has literally hundreds of releases that it's gone through. The Chrome driver right here, this guy, this is the thing, this is like a piece of software that was written to allow Python to control Chrome. And it turns out that each version of Chrome driver only supports like a super limited range of Google Chrome itself. So like, maybe think of it as like a 1 to 3. Like every one version of Chrome driver probably supports like 3 releases of Google Chrome. So if you don't have the exact right combination of all these dependencies, you're toast. It's just not gonna run. So I made this up, but just imagine with me that this is a winning combination. You get these versions on your machine, it's gonna run just fine. So that was my 10 hours solving that problem, trying to figure out exactly where to put these green boxes. But I actually made up a lot of these numbers, so of course I made up the combo. Okay. So back to my like original like just rant, you know, to the world. Like surely someone has come up with a way where like I can just take someone else's solution. If someone has surely put together all of these packages and dependencies with all the right versions already, so why can't I just leverage that, you know, something that's already been done? So like a typical solution to this problem in the past is something called a virtual machine. So the idea of a virtual machine is you simulate a computer inside of a computer. You simulate an operating system inside of an operating system. Like if that doesn't make sense, I have a slide on it later, but just imagine being able to download a whole operating system that already has the dependencies and the versions that you need for your app. So it was a good solution. Like this is really popular. People use this. So let's talk about the old way software was put into production. And like, I'm sorry if this puts some of you to sleep because like, you know, if you've been in software, you know all this stuff. But like, just imagine for a second, this is new, exciting. So if you're a company and you want to run an app, you're going to buy, in the olden days, an entire dedicated computer that you're going to run your app on. And on that computer, you're going to run some kind of operating system. And then in that operating system, you'll run one instance of an application. You could run more, but if you run more, then they might like, well, if you run multiple different types of applications, their dependencies might clash. And so there's just lots of maintenance reasons why you probably want, for maximum scalability, to have one application running in one environment. So the disadvantage of this, though, is if you want to scale up and have multiple instances running, then you would literally have to buy multiple dedicated servers, which is, you know, there's a lot of bullet points here, but basically that's just a nightmare to have to maintain so many machines. And so, again, someone was like, surely there's a way that we can optimize the way we're leveraging our hardware resources here. So this is the virtual machine. This is like a classic. We have like Windows inside of Windows right here, so you're simulating it. If you want to make a virtual machine, you can choose the operating system that you run. So you could have like Linux inside of Windows or something like that. So the way this runs is like you have your machine. It runs a special kind of operating system called a hypervisor. This is in production. VMware is a common one. On top of that, you simulate multiple computers running entire systems. And each of the systems gets one app. And they could be different apps. So the pros of this are like, you know, if I want to run multiple instances of this app, I just clone the VM, like not a big deal. And I can run multiple of them on the same machine, which is a huge improvement from having to buy multiple machines to run my stuff. The cons, though, are still, like in most cases, if you're going to run 2 Windows virtual machines, even slightly different versions, you better have like 2 copies of that operating system. So that's a lot of space. Also, you have to allocate your resources on your machine to those VMs. So like, say you got a terabyte hard drive, you want to run 5 VMs, you might split that into 5 pieces. But then if you want to start a 6th, you've already allocated all your space. So, you're still competing for resources. So it's better because we're running multiple things on the same machine, but we're still pretty limited. So, and then by the way, if you're not familiar with cloud computing services, there's these big 3 companies right here, like Amazon Web Services, for example. And when you buy resources for cloud computing, a VM is what you're buying. They have big warehouses filled with computers, and they're just running VMs that people can use. If you want to do that, you go to Amazon.com, pick the operating system you want to use, maybe Windows, maybe Linux, and when you're done, you get a terminal. And from that, you can control their computer from afar, and you can put your application there. So that was virtual machines on a hypervisor. If I wanted to do that on my laptop, I would have my laptop, and then I would have my operating system. Then on top of that, I'd have a hypervisor, and then I would have my VMs. So by the time you get to running your app, you're going through these 3 layers of computation. So your processor's it has to do a lot more than just running, an app that might already be intensive by itself. So enter Docker. Yes. This is hands down favorite buzzword of 2019. Great technology. So here's the Docker solution to the problem. So I just talked about VMs. We're going to talk about a more resource efficient way to handle the same problem, which is getting your environments all packaged. So you have your computer running, and then on top of that, you run Linux. If you don't run Linux, you virtualize Linux in a VM. And then on top of this, you're running a program called the Docker engine. And this is just a program running on your operating system. And that program uses files called images. So up here, here's the web scraper. We'll just say, here's the web scraper I wrote. So here are all those dependencies I talked to you about. And then here's my file with those guys. And say that for some reason it makes a lot of sense to run my web scraper, particularly in Alpine Linux. And I would also include pieces of the Alpine Linux operating system in this grouping of files. So this is not a VM right here. These are just files sitting on your computer. And those files sitting on your computer are called images. So just think of images as that bucket of dependencies that you need. So then when you actually want to go and run it, you start an instance of those files. So this is something that I think people get tripped up on a little bit. It's we're here to talk about Docker containers tonight, and people always talk about putting things in a container. That's not technically accurate. You put things in an image, and then you run a container off of that image as an instance. And so imagine you've got a little Python script sitting on your computer. It's fully within your power to run that script 5 times at the same time. Does that make sense? So these files, imagine all these files together just like a Python script. I could start multiple instances of all of them. So we're running multiple containers. And also, this is not VM, this is not virtualization. We're not dividing up pieces of our hardware, for each of these instances. Rather, we're just running multiple instances of the same program. So all the work is actually happening directly here. There's no little layers of virtual machines there. Yeah, any questions so far? Or does anyone want to add something? Did I mess something up? Cool. All right, so I was gonna go into what makes a Linux distribution unique. I'm just gonna we'll talk about this. I'll just sprint through real fast. So you've probably heard of different Linux distributions. Have you heard that term? There's Ubuntu, there's Alpine. So this is a gross oversimplification, but really, at heart, where those things are all different is actually the application layer. So they all technically have the same Linux kernel, or the same vanilla Linux. But when you get a different distribution, you can think of it as getting the Linux kernel plus a couple of extra programs that go with it. So that's it. So if you look at these guys, we're not running an entire Ubuntu and an entire Alpine. We're running the host Linux, and then we have the special files that characterize Alpine Linux, or that define Alpine Linux. So we're already really running the vanilla Linux here. So on top of that, you just have some extra files that are necessary for you to call your environment Alpine. So that is probably confusing. A question here would be nice. If not, that's totally fine. Does that make sense? Okay, cool. I was so tripped up, so I'm actually surprised and humbled. So now imagine you want to make two different images, but you don't need two different Linux distributions. Like as a normal person, why would I ever say to myself like, oh, I want this app to run on Alpine, but I want this app to run on Ubuntu? Like chances are I just want Linux. And so actually there's something called the union file system, which allows you to share like dependencies that are installed. So I have two images here. I have a web scraper image up there and I have an RScript image. But I don't have two copies of Ubuntu. They're using the same copy of that on my hard drive, which saves like a lot of space. Because remember before we talked about how you had to have copies of like Windows OS. So say I wanted to do two different web scrapers, I could actually share those dependencies too. And so the only places where those images would be different would be two different Python files on my computer. So yeah, that kind of tripped me out. So we just talked about images. I should say that this hashtag, I did a hashtag for this. When you make an image, you give it a name, and that's called a tag. So I did a hashtag. So we talked about how different images can share files on your computer. So Docker as a company, they maintain certain images that are really high quality that you can use as like a starting place for your apps to like bundle them into an image. So a really common one is they have a great Ubuntu image that they use. And then, so the title of the meetup is Docker for Data Scientists. Oh, yes, Rosin.
On the previous slide, are these still sandbox or are they running in the same OS?
The containers?
Yeah.
They're all instances, but they're totally sandboxed. They can't interact with each other or interfere with each other unless you give them exclusive permission.
So even though they're sharing all the same files, they're not going to have dependency problems or like call the wrong program.
Yeah, exactly. So
one thing to maybe point out here is the write. How is it? It's a write file system. What was that?
Copy on write.
Copy on write. Yeah. So that each image, so each instance here gets its own, as the file system isn't a standard. It's a copy on write, and so if you make any modifications, those aren't saved on top of the original files. Those are saved in a new layer. And so that's why whenever you clear out your image, you get and you maybe restart one or get another instance. They're each independent and you'll always start back at that same starting point, because when you close down that instance, Docker says, cool, we're done with all those extra writes that we've done. We're just gonna wipe those out.
thank you for that. Did that answer your question, Rosin? Cool. Yeah, any other questions or comments that you just want to throw in? Yeah, feel free to stop me because I'm just going. So that's an image right there. You can actually, when you go to build an image, where I'm getting at here is when you go to build an image, you typically don't have to worry about the very bottom here. Like usually someone's going to make an awesome solution for you. So for example, when I made my web scraper, someone had already made an image that had all my dependencies in it. So the only thing that remained for me to do is add my Python script. So Docker team maintains like a Ubuntu image, for example. And I'm assuming most of you have heard of Jupyter Notebooks, but if not, it's just a tool you use to develop in Python. The Jupyter team maintains a lot of great Docker images that you can use that solve a lot of like common data science problems. So on top of the Ubuntu image, they added Jupyter as the Jupyter service and Python and Anaconda. So if I go to download the image with this tag, I secretly also download the image that underlies it, if that makes sense. So their team just went and added some services, and now every time I want a great Jupyter environment, I just have to download their base notebook. But they went on, they built on top of this. So in their minimal notebook, they added a ton of extra packages, like the things you would want, like Git and I don't know, other packages. And then they have a SciPy notebook where they install like pandas and some other data science tools. On top of that, they have a TensorFlow notebook, which like in the data science realm, if we talk much about deep learning, TensorFlow is like notoriously annoying to install. It's just like not a good time. Like you might have C dependencies that are clashing with each other and stuff like that. So to me, it's a big deal that Jupyter has just put TensorFlow inside of a Docker image, because now I never have to worry about it. I could just install this. And so say I had a TensorFlow script that I wrote and that, I thought was awesome, then I could make my own image and add the TensorFlow script on top of that guy. So I could even publish this actually so that you could download the image located at Eric/awesome deep learning project, and you would get my script that I published and all the underlying Jupyter dependencies. So it's just great. Like, so for my web scraper, it saves tons of time. I just Google, hey, Docker image with working Chrome driver and stuff, and I find it. So again, the union file system, I'm kind of beating a dead horse here, but like, you might have the image with with the TensorFlow thing. I could have 2 images with different TensorFlow scripts on it, and it wouldn't be taking up extra space on my computer. As an extreme example, so say you've got Ubuntu base. On top of that, I could get the Jupyter SciPy notebook, and then I could make like a data cleaning script on that. But also I could have a TensorFlow script, and also I could have an image with like other applications like Airflow or something like that. And then these are just files on my computer. So from that, I can start up as many instances as I want of them. And none of them can see each other. So yeah, that's a lot of stuff. If I'm losing you, please stop me. But at this point, I just wanted to, that's really all the theory of Docker. So if it's okay with you guys, I want to just like run through like an example project. Like what does it actually look like? Yeah, Dustin.
I would add a best practice. Trying to build an application and import it into Docker can be challenging.
Okay.
It's often better to start right away with Docker because you still have the versioning problem. Just in that case, the versioning is dealt with for you. If you build it on your system, your versions may not match your Docker images that you find, and then you're gonna have to go through the porting and make that compatible, right? So it's often better to just start out with a Docker image and develop right into it effectively, and then ignore all the versioning issues that you get put in your direction.
Cool, thank you for that. Yeah, also like, oh yeah, please.
I'd also mention the difference between images that use Ubuntu and Alpine.
Okay, sure.
What are the advantages there?
So that's a great question. What, how should I do this? I think I'll get to that in the next slide. So let me just tell you now, like how do we actually build a Docker image for our app? Like we know that it's great. You can download environments, so let's use it. So the way that there's 3 steps. So the first thing you do is you make something called a Docker file. And this is one file you write. It's really simple. And I think of it as like a recipe for your Docker image. So you're just gonna, in this file, like a config file, just gonna define what's gonna be there. And then you run that, you build, from the Docker file, you build the image. And then when the image is sitting there, then you can run a container. So let's make a Docker file. So what we do, these are different commands that can go in a Docker file. Don't worry about these, we can like reference them. So we're gonna code right here together in PowerPoint is what's gonna happen. So first line, every Docker file, you need to know what image you're building your app on top of. So for me, that was like an image that had Chrome stuff in it. But this app could just be some basic Python script. So the image, this is the image I chose. Yeah, let's answer your question. So let's just kind of go off the rails. So like in this step, you're programming something. You need some dependencies that you're going to use, and so you can come to. There's a website called hub.docker.com. It's a lot like GitHub, where like Docker images are just open source, and so you can kind of shop around here for what you want. So on their website they have a search bar. So if I'm writing a Python app, then I could come here and I could write Python. And so I'm looking around, and these are all Docker images that already exist. These ones that say official image, these are actually maintained by the Docker team themselves, and so you can trust them. And that's important because these are just software packages here. So if you just go and install some random Docker image, like there could be something terribly crazy that could hurt you inside of a Docker image. So you just got to be careful and not, and be selective about the ones you choose. So a good way to handle that problem is here they have the number of downloads that an image has, and that's usually a good indicator of it being safe. But if it's an official image, you're good. You don't have to worry about it. So we're making a Python app. Let's dive in here. Scroll to the bottom. Actually, no. So this is when you click on an image, you get this page. These right here are tags. Tags are the name of an image. Tags can have a version component of them, and so these are just like these are all different versions of the Python image. So, and what's your name?
Justin.
Justin. So a point Justin brought up is that there are different versions. One of the differences between these versions is some of them run on different distributions of Linux. So if you're particular about what distribution you're going to use, you need to pay attention to the version numbers here. I'll talk about that in just a second. If you scroll to the bottom of these pages, they have like a little bit of, they'll always have some info on how to use the image. And so what we're seeing right here, oh man.
I wish I could have this.
Your code is wrong.
They are testing the generator, so there might be other power glitches.
Is it gonna explode? Wow, that's great. If I put you to sleep, that was helpful. Yeah, so we're looking at instructions basically. How do I use a Docker image? Which one do I choose? So say I'm looking at this image. I see that this is the Python image, so then it's really just like, what version do I want to use, and here's some instructions. So one thing to note is different Linux distributions can be heavier than others. So like Ubuntu, for example, I think is like 5 gigabytes, but Alpine that he brought up is a distribution of Linux. It's only 5 megabytes big. It's like ridiculously small. Like, yeah, again, like VMs were a problem because they were consuming so much space in your hard drive. You could get a distribution of Linux that's like this big, 5 megabytes, and then your apps are super small. But then again, a con to that approach is because it's so minimalistic, there's like nothing there. So like if you need Git or like the ls command inside of your image, like you're honestly out of luck. Like there's like nothing there. So I was actually reading a blog post on this leading up to this, and this guy was very opinionated. He really believed that Buster is the best choice to choose as like your go-to image. So the reason being is it's smaller than Ubuntu, but it has all the packages you would typically want developing with Python. So just note, Buster's a good choice. So we're gonna choose Buster. Let's get out of here.
Also mention that there are other repository services besides Docker. For instance, if you're looking to work on Google Cloud Platform, they run at gcr.io. That is a bunch of images sort of optimized for their platforms.
Okay.
So if you're looking to throw your system to the cloud, you can always look up that particular cloud and see what they have for optimizing performance on their systems.
Yeah, that's a good point. Like I know at our work we use Amazon Web Services. Amazon has like a little, I think it's called ECR, Elastic Container Registry, and that's just like a Docker hub that you can that is private to you and your organization, so no one can see your images. And like Docker hub.docker.com lets you do private images that the world can't see, but they start making you pay after like one private image. So typically, like once you get really moving with this, you move to some other custom registry service to like host like all your images. So yeah.
I just want to point out on that subject, if you're beholden to whoever is running that registry, Docker Hub last week had an issue. And so there were a lot of things that we couldn't do because our CI was dependent on the Circle CI image in Docker Hub, and it couldn't reach Docker Hub.
Oh yeah.
And so if it's a lot more reliable to host or run your own registry as well, because you can control that downtime.
That's awesome. That's a great point. Yeah, so we use Amazon Web Services at our work, but I'm sure any cloud vendor that you can think of probably has their own registry service because it's just an easy way for them to lock you in and take your money. So because Docker is great. So, okay, first line here, from Python, and then the version of the Python image that I chose is 3.8 Buster. So now you know that Buster is a good version to default to. So, and then as these lines come up and down, like I'm trying to show you that like they're associated with layers in your image. So like Buster is technically a flavor of Debian. So the bottom here is like the Linux we're using, and Buster, it's a Python image, so like it naturally has Python in it too. So so the next command we usually run is like some kind of run command. So what run lets you do is just like run bash commands, whatever bash commands you want. So this is just an example. I'm installing BS4, which is a web scraping library. So there's the box appearing. And then we copy our application into the image. So the syntax is source destination. So source is on my machine, destination is in the image. So you just need to find out where files should go in the image, and then you just plop them in there with the copy command. And then the last line doesn't add a layer to this image layering thing. The last thing you always end a Docker file with is some command that says how to actually start the container. Like, yes, the dependencies are there, but like you need some command to actually get your application running. So the syntax is a bit odd, but to run a Python script, you type Python space and then the name of your Python script. So what you do here is like use this kind of list syntax, and everywhere you see a space, you just split that with a comma, and I'm told that's best practice. Yeah.
So does Docker allow you to schedule scripts to be run, or do you still need something like Airflow to kick it off?
That's a great question. Docker by itself, I would say, does not, but Airflow works really seamlessly with Docker. So I actually have a slide on that at the end that I wasn't going to show, but now I'll show it. Yeah. So this is our Docker file. Like, it took me like 10 minutes to get here, but this is only 4 lines of code. So, I mean, if you were working on a project, you would have finished this in the time it took me to explain this.
I'll add too, you don't have to include that last command line there.
Oh, yeah?
You can if you'd like, but you can actually just, when you run your instance, create a container, right, from your image, you can just give it the command you'd like it to run. It could be variable, right? So that you can do it. So you don't have to have that there to actually use it.
So like parameterize your images.
Yeah.
Awesome. Thanks. I don't think I've ever not put this in a Docker image, so that's good to have added.
So that way, every time you create a container from that image, it's going to run that exact command. But maybe you don't want it to do it this time. Maybe there's multiple scripts in there potentially that you want it to run different things in different instances. So
Yeah.
you can tell it at the run command. I'm sure you're going to talk about what it does that way, like how to.
And you can also, even if you put a command here, you can always override it when you go to start a container. So yeah, so there's a Docker file. That's our recipe. And then you just run this command. So this is the build command. -T is for image tag, so we're just going to name it. And this is usually the syntax you get there. It's like some username, name of the image, and then a version. So we just saw that. So if I wanted to run the Python app we just built, this is the command. So username and version at the end. In the build context, I think that's a complicated name, but basically like in your terminal, you like cd into the folder where your files are, and then you just put a dot for current directory. Yeah. So, and then, yeah, these steps are so fast. Then you just run it. So we have the image, you just run a container. That actually ends the theory of the presentation right there. So we had a question about orchestration. There's a great tool called Airflow, and there's other tools that do this too. Basically what their job is to execute like applications in order of dependency. So it's like, say I have like a web scraper that runs, and after it runs, I have some data, so I have another script that cleans it. Then like Airflow would run the web scraper, and after the web scraper finishes, then it would run the cleaning script. If the web scraper failed, it just wouldn't run the rest. So it's just an awesome service that, I mean, if you know what cron is, it's like super cron. So like one cool thing is that like, say you wanted to deploy an Airflow server to production, Airflow can actually start up Docker images. It can start up containers from Docker images. So like, as an example of Docker in production, when you use Docker in the cloud, your things just work. So, and that's it for the presentation. I just wanted to go through the theory, and thank you so much for your time.
You go back to that.
Right here.
I was actually just following along, and I fall into that category of super new Docker user.
Yeah, totally.
But, never mind. I think I got to the period at the end.
That's impressive if you like were able to like keep up and type all this and to get this command.
Building it.
No way. Awesome. Yeah, so, I mean, the rest of the night is yours. I mean, Mariah probably has a few things to say to end this. Yeah.
How do you typically deal with like sending and receiving information? Like if you want to connect to an API and making sure other people can't connect to your Docker, things like that. What is the best practice with that?
So if you're hosting like a web service out of a Docker container, how do you basically lock it down so only you can access it? That's a good question. So I don't know if I know like every way to answer this, but like one cool thing about Docker is that it starts out giving no access to external services through ports. So like say I run Jupyter Notebook that runs on port 8888. I have to explicitly give permission to run on that port. Once I've done that, then technically the world can get in. So I would say if I were solving that problem, Amazon Web Services then has abilities to like restrict who has permission to even make requests to the computer that the Docker is running on. So
Be a firewall external to the Docker container.
I mean, wouldn't it be no different from keeping them from getting in a web service that you're hosting just on a physical server?
yeah, I think it'd be the same. So
Yeah, following up to that question, how easy it is to scale up and down the servers based on the demand and load?
oh, it's so easy. It's awesomely easy. So Amazon Web Services, for example. So yeah, like your typical web architecture is like you run like your web server. Its job is to like serve a website to someone. And like if 10,000 people go to access it, it'll die because that's too much traffic. So then there's like a load balancer that's introduced for like you have one computer and then you have like 5 instances of your web server, and this load balancer decides which web server to send the traffic to. So Amazon Web Services has a service called Elastic Beanstalk, and that's like a load balancer that auto scales for you. And a really cool thing about their service is you can just give it a Docker image, and you don't have to worry about any of the VM things happening in there. So if you just look into Elastic Beanstalk, it manages that for you, which is really cool.
Thanks.
Yeah, you're welcome. Yeah, if there's any other questions, or like if you guys just want to like get out laptops now and play with Docker or just network and talk to each other, like everything's good. No typing. Science.
This may be a dumb question, so excuse me if it is. What's the difference in this and like Kubernetes?
The difference between Docker and Kubernetes? That's a good question. So I want
to hear you answer the question. All on the floor.
I'm gonna need help answering this question, but I can probably start us off by saying that like they can coexist. Like I wouldn't say one inherently replaces the other, but I hear that people use Kubernetes as a service to manage the starting and stopping of Docker containers. So like
And the restarting.
is that all right? Please answer this question. What do you guys think? There's so many blog posts on this question that like you can read about for days.
You're gonna speak. I'll let you answer it. And then you want to hear my BS because it's not.
Starting and stopping, but you usually call that scheduling.
Yes.
And so, yes, you're scheduling and orchestrating Docker images in a cluster. So not on the same box, but on several nodes. And so it's more of an orchestration. So yeah, definitely Kubernetes is dependent on Docker because that's what it uses to distribute loads on.
Hey, Eric, go back to the slide that you had the Docker images on top of your kernels, your Linux kernels. I think that would be the best way to explain it with that visual. Yeah, right there.
There.
So right here, he had everything on a computer server. Well, the whole purpose of Kubernetes is to say, okay, instead of putting it on a local server, we're going to throw it up on the cloud. So now Kubernetes it replicates the idea of your local server inside a cloud instance. So that's basically what it's used for, and it's a tool that then manages the deployment and updating of those things on that cloud server. That's super high level, but that's the relationship of it. So then you see Docker being installed inside the Kubernetes container because Kubernetes is acting as your machine, and then Docker is controlling everything inside of it. You can correct that.
No,
That was
I
just
don't
my
think there's-
crazy high level.
Depending on where you're coming from, there's another one I like to use is it's the system D of Docker. So it's across, but that'll only appeal to people who are in operations.
Yeah. All the way there. You have another.
Yeah, question back here.
Yeah, so you mentioned Elastic Beanstalk. How does that relate to orchestration? Like, are you still sharding nodes? Like, if you want something really scalable, like where does that occur?
How does Elastic Beanstalk relate to orchestration?
Yeah, or like, if I wanted something that was really scalable and like normally like sharding or like things like that, or replication, does that take care of that for you? How does it scale that, I guess, or like what?
I'm not super familiar with sharding because I usually use that term in terms of data.
Oh, okay.
Yeah, did you want to try that?
That one.
Typically, so Elastic Beanstalk is gonna help you scale your application layer. It's gonna take care of, rather than running Kubernetes and trying to manage all of that yourself, you just hand them a Docker image and say, here, run this, make sure that it keeps running, keep adding more instances if I need to. So basically you hand them an image and they hand you back an endpoint and say, here, it's hosted here, just access it there. But you're still gonna have to connect and manage your databases separately.
Okay, that makes sense.
Yeah, that's a great question. Yeah, Rawson.
When an application fails, like if you're using Beanstalk, does Beanstalk kill these applications all on its own and relaunch?
Here's an application, this application running.
When an application fails, I would assume so. I haven't actually used Beanstalk enough to have done that. Yeah. Anyone know the difference between Kubernetes and Docker Swarm?
Nobody, yeah, Docker Swarm lost.
Yeah.
And they
Kubernetes meetup was last night?
Oh,
Kubernetes was last night. Yeah, there's other alternatives to Kubernetes and Docker Swarm. Like it has like a farmer sounding. Yeah.
Rancher?
Rancher.
Yeah, rancher. That's what literally the opposite of farmer. Yeah.
I'd be lost there for a minute.
Yeah. Anything else? Questions, concerns, rants?
Let's give Eric a nice.
If you guys want to, I can post the slides on the Slack channel.
Yeah. That would be nice.
I forgot a period at the end of that last command, so
Oh my God.
Ah,
perfect.
Cool, sorry.
Where is
Common
the?
mistake I see in using Docker, people don't start up the Docker manager. They run Docker commands and nothing happens. And they respond to it.
Is it gonna tell me that I broke Wi-Fi? Wi-Fi this thing.
also, one other thing to remember is that if you install Docker for Windows or Docker for Mac, that's running a virtual machine on your computer. So if you suddenly get slower, go try turning that off and get your computer back.
I'm just trying to share my screen so that you know that my raffle is random.
The container.
Everybody's leaving because they don't want my footprint.
Investment started.
Azure is like, it's like AWS, but it's hosted on Microsoft. So it's gonna be
Applied math, actually. Yeah. It's like the nerdiest way you can go, except for CS.
All the other clouds are typically Mac-based, so
Yes.
what is the secondary option? Azure is Windows.
I tried to take as many in this class as I could, just because I wouldn't be able to do anything without them.
This isn't my job.
The big data class? So there's a capstone class and you can choose if it's gonna be like data engineering thing or like some sort of software project.
I'm a backend engineer.
Funny story, I signed up for the big data one and then BYU didn't want to.
I am now gonna just put random names up if somebody says I'm here.
What you asked, did you do it?
Sean Hamilton. Nope. Prakash. No.
Oh, no, wait.
Benton? No.
Probably
Brenda.
not.
You just won a software license for IDE. Does that
I
make
feel
you
like you
feel?
should do it to someone else.
Okay. You want to give it to Eric?
Give it to Eric.
I already have one though, don't I?
Oh, yeah, you won one.
Well, you can use, you don't have everything in their suite though.
That's true.
Oh, you can get another
I
one.
get 2 years of Pro Edition JetBrains. I actually don't even like
There's
JetBrains.
totally an expiration date in January, so.
Speaking of getting locked into a service again.
Just not a huge fan of JetBrains, period. So.
Cheetah? No, no, that's me. Oh, this is cool. Thank you. You're welcome. Okay, I'm gonna open the door. Feel free to grab more food, hang out as long as you want. I'll be here. And so will Eric.
I have another question.
And I love that you came though, so you already like, like,
So,
this was like less than new.